All right, so, oh, you can't see anything because of the glare. Well, good luck, Skylar. All right, so we got 0.008 moles of BaCl2. That came from the 0.008 moles of BaCl2 over here, which came from the moles of the BaSO4. So you use the mole ratio to get that. So this times, let's see, what's the molar mass of this? 70 plus, that's a big number, right? Yeah, 137. What is it? 207? 207 grams per 1 mole. Moles cancel. So we end up getting grams of BaCl2 is they got 1.663 grams. Yes, of BaCl2. 1.936 minus 1.663 grams, because this is the total mass. This is just BaCl2. This is going to tell us the mass of water. Mass of water, 0.273. 0.273 grams of H2O. So now we know the mass of this. We know the mass of this. We convert them to moles. We already did that. 0.008. So let's take 0.273 grams. 0.273 grams times 1 mole over 18 grams for water. So moles of water, 0.0151. 0.0151 moles of H2O. So now it's 0.0151 divided by 0.008, and that should be 2. So that means you have twice as much water as you do BaCl2, and that's how we do this. So the answer is 2. So it's actually not that tricky. It's really not. They give you this, you just have to find the moles, and it's always going to be the same, and then convert it to grams and subtract. The rest of this is not, the actual math isn't that hard, it's just the concept. What do I do next, right? What do I do next? So what do I do with that number? All right, so that one worksheet you have, practice hydrate problem, that's due tomorrow. It's just like this. This one, empirical molecular practice problems. We did some of that last week. This Friday, I'm going to give you a quiz. And the quiz is going to be on empirical molecular formula determination. I'm going to give you one limiting and excess problem. I may give you one of these, I don't know. But it's going to be on empirical and molecular and on limiting and excess. So by the time that gets here, you should be good with limiting excess, I think. Maybe I can find another. There's tons of those out there. I can give you another one for like review practice. But these two are supposed to be review for that quiz on Friday. All right. I'm giving it to you now because the rest of the week we're doing this solution stuff. Okay. So you can put the work right on there if you want. I'm not collecting it. I'm just going to either come around and check it or we're going to go over it. So it's just normal homework. I just put it on here because I think we did all the good ones in the book already. Okay. All right. Moving on. Okay, so now we're going to take what we have learned and apply it to solutions. Oh, wait a second. When did I say your problem set was due? Ooh, I didn't write that down. Take that out again. Quick here. Did I tell you what chapter would help with that?
Yes,
No?
you did. But then,
I think it was. I think I told you chapter 4. So let me just make sure you know what's going on with that. You want to push that to Thursday? Let's do a problem set Thursday. The demonstration thing due Wednesday, and we got a quiz on Friday. We're doing a lab Wednesday, but that won't be due until next week, so let's not worry about that. Okay? So, the problem set. You definitely should not just work on it by yourself. You should work together, talk to each other, ask me questions. Alright? I want net ionic equations. I don't want ionic equations. And again, just a simple example. If we have silver nitrate plus sodium chloride, NaCl, that makes silver chloride and sodium nitrate. This is a double replacement precipitation reaction. This is insoluble, so it's a solid. It'll be a white solid. The ions, the Na plus and NO3 minus, have nothing to do with this reaction, so these two ions don't belong in your final answer. So your net ionic. Net means, if you guys know what net means, is like gross pay. Like I make a certain amount of money, but then there's taxes and other things taken out of it, and then what I actually gets put in my bank account is my net salary, right? So I think you guys probably have all heard that or get that, I hope. Same thing here. Here's like the whole thing, like the gross reaction. The net reaction is the only parts that actually react. So it would be Ag plus Cl minus yields AgCl solid, AQ, and AQ. And if you need to balance it, then put the coefficients in front. So for all of those reactions, if there's a net ionic, not all of them have that. In other words, sometimes every part of the reaction reacts. All right, but in a double replacement, only 2 ions are going to be involved. Okay, so hopefully most of those on there aren't too bad. There's a couple that are tricky, and I think number 3 is kind of tricky, I said. I will give you some help, you know, but you got to come see me. I really suggest you work together, talk to each other, look them up in the book. Obviously, you have the internet. But again, I caution you, if you just look up the answer online and just copy it down, you know, I really won't know, but you're not helping yourself. I want you to try and figure some things out, all right? The book is helpful. Chapter 4 is helpful. All right? So, I just wanted to make sure I bring that up again. So we'll make that due Thursday. All right? Demonstration we'll do Wednesday. And if you have questions, just come see me. Free period after school or something like that. I'm leaving early today, but just fine, talk.
You're leaving early today?
Yes, leaving at 1:30. What do you guys need to do in that lab? You're all done? Did you hand it in? I didn't check the pile. So you guys didn't need extra time or anything?
No.
Okay, all right, good. All right, moving on. All right, so we're in a good spot here. Let's do. All right, so moles in solutions. That's kind of what I title it. So we're talking about solutions now, which is kind of like the problem set. Molarity is what we focus on. We don't really do anything with parts per million. So molarity is a concentration. It's moles of solute over liters of solution. SOLN is solution. So the unit for molarity. So if you said something with a molarity of 2, it's capital M, or you could go 2 moles per liter. I'm not going to practice any molarity problems. They're very simple. It's just simple. That's it. There's the formula. So I'm not going to do any of those with you. So you're going to have to use this for what we're going to get into. But I'm not going to do any simple. I'm not going to give you problems like, okay, you have 2 moles in 100 milliliters. What's the molarity? That's Regent stuff. That should be easy. We're going to not do that. The only thing I will mention, though, that gets a little confusing with this is if you have an electrolyte and a non-electrolyte. Electrolyte versus non-electrolyte. You know what? Give me 1 minute, and maybe I can find something. It's more fun if I have an animation. I know there's something here. If I can't find it quickly, we'll just skip it. It's not bad. I can draw it. Do you guys remember what that means from Regents?
What?
Electrolyte versus non-electrolyte? Yeah, this conducts electricity in solution, this does not. This dissociates, this does not. So electrolytes are acids, bases, ionics, This tends to be covalent or molecular. Electrolyte, they have ions. So I'm just going to write ions here. Over here, there's no ions. So the word dissociate means break apart into ions. So electrolytes dissociate into ions, non-electrolytes don't. You guys remember that crazy video I played a whole bunch of times? Add a solute. Boiling point goes up. Add a solute. Freezing point goes down. Colligative properties. Depends on concentration, right? Those of you who are, do you remember that at all? So that's what this is. I'm just summarizing that. I'm not going to reteach that. And actually, they don't ask that on the AP test. They took it off. But you need to know the concept moving forward. So what that means, I'll give you three things here. So if we have glucose, C6H12O6 solid. If we have potassium iodide solid, and we have we'll keep it simple, calcium chloride solid. And you put all three of these in water. Okay, so H2O, H2O, H2O. So you make 3 solutions. And let's say you have a molarity, so this is here, I'm trying to make it simple here, I'm not trying to confuse you. Let's say we have 1 mole of each of these. 1 mole of each. And let's say we're putting the 1 mole of each one in 1 liter of water, okay? 1 liter, 1 liter, 1 liter. So the molarity would be 1, right? Moles over liters. So the molarity would be 1, that's where I'm going with this. All right? So when you put a non-electrolyte in water, if it dissolves, if it dissolves like, they have similar forces, if they dissolve, they will dissolve, but they stay together. The particles, the individual atoms, they don't dissociate. There's no ions here because it's covalent. It doesn't have ions, so it doesn't break apart. So what you get is you get a 1 molar solution of glucose, which means you have 1 mole of glucose kind of floating around, 1 mole of particles. These two is different. Over here, you get a 1 molar solution of Ki, but it actually dissociates. So you really have 1 mole of K plus and 1 mole of I minus. So if it's an electrolyte, acid-base ionic, this is ionic, it dissociates. So again, if you know it dissolves, so yes, we know it dissolves. Now what does it do? It breaks apart, dissociates. So now you really have 2 moles of particles floating around. You have 1 mole of K plus and 1 mole of I minus. So even though you have 1 mole of the compound, you actually have 2 moles of the ions, 1 of each. Down here, 1 molar calcium chloride solution, AQ, you really have 1 mole of Ca plus 2 and 2 moles of Cl minus. So down here, you really have 3 moles of particles floating around because you have 2 Cls. So we're taking previous knowledge of molarity in solutions and we're going to apply it to some new questions here. And you have to take what you've learned about limiting and excess too. Things build on each other here. So I'm kind of getting right into the AP level stuff. This we did talk about in Regents, but this was it. All we needed to know in Regents was that this has a higher concentration. This has 3 moles, this has 2, and that has 1. And a lot of Regents kids, maybe some of you never really got that. That's okay. But hopefully now you're a whole 8 weeks more mature, 10 weeks, whatever it is. It's always funny how we say last year, it wasn't that long ago. But you know what I mean. Hopefully now it's at least clicking a little better. This breaks apart, 2 moles. This breaks apart, 3 moles. So, electrolytes always produce more particles in solution than non-electrolytes because they don't break apart. They stay together as molecules, so these influence concentrations way more. That's the whole point I'm trying to make. They dissociate. Okay. So now, so that's kind of like, all right, let's take what we learned, the basics here, and let's apply it. We'll do that later. We got to do dilutions, but we'll do that later. All right. Okay, we'll start out with a fairly simple question, and then we'll get a little bit harder, and then a lot harder. Okay. The lab on Wednesday is called gravimetric analysis. Did I tell you already? We're going to find the hardness of water. Has to do with ions floating around in water. So this is why we're starting here. Okay, we got some time. Let me give you a problem just to get our brain working on the solutions, and then we'll move on. All right, so here's the question. Typical blood serum is about 0.14 moles per liter salt. What volume of blood contains 0.001 grams of NaCl? All right, so if blood serum is, what's that number? 0.14 moles per liter of NaCl. So they're just telling you that. They want to know what volume of blood has 0.001 grams of NaCl. So this is involving molarity, obviously. So you know if you have a liter of blood, you have 0.14 moles of NaCl. That's what that number tells me. If I have 1 liter of blood, I have 0.14 moles of salt. You can figure out how many grams that is using the molar mass. So they want to know, okay, what volume of blood do you need? Think of it that way. What volume of blood will have 0.001 grams? Right? So it's not going to be the same. Right, so again, 0.14 moles of NaCl per 1 liter of blood. That's what that number tells me. So really, I just need to know what volume do I need here to give me 0.001 grams of NaCl. So I have moles. You got to make sure things are in the same unit to kind of compare. So I'm going to give you a couple minutes, see what you got. I'm going to eat this banana. Then we'll come back to it. Alright, this is how I did it. I just took 0.001 grams, turned it to moles, and then did a proportion. So 0.001 grams times 1 mole over 58 grams. So for my moles of salt, the 0.001, I get 1.7 times 10 to the negative fifth. Yeah. So now I just cross multiply and divide. So really it's just this number divided by 0.14. So to keep the same ratio, right? If this is the ratio in the blood, and this is how many moles we have, how much blood do we need to keep the same ratio? It's 1.2 times 10 to the negative fourth liters. Who got it? Couple? A few people? Okay. So, yeah, this is just a practice problem, just being familiar with the molarity and moles calculus. Remember, it's all about units. It's all about units. So we need to keep the moles per liter, and we need to keep this ratio. So if it's telling you the concentration of blood is 0.14, how do we keep that concentration? Well, if you know how much salt you have, it's obviously going to be a much smaller amount of blood, because this number is way smaller than 0.14. So you need to know the unit there. It's moles per liter to help you understand the concept. So if it's 0.14 moles in 1 liter, you're going to need a little tiny amount if you have a little tiny amount of salt, right, to keep that same ratio. So it's 1.2 times 10 to the negative fourth liters. So if you were to divide this number here by this, you would get 0.14 to keep the same concentration. Okay. So again, the point of doing that, using the molarity calculation, the units, and applying it. Okay. All right. I'm just tired. 10 minutes. All right. Here we go. I'm going to give you a precipitation problem, which is kind of like a limiting problem, but just in solutions. Here we go. Write this question down. Calculate the mass of solid sodium chloride. So calculate the mass of NaCl that must be added to 1.50 liters of a 0.100 molar solution of AgNO3 to precipitate all the Ag plus ions. So, what did Dorothy say? We're not in Kansas anymore or something? I want to go home. What happened down here? What's
Just
that?
lots of things.
What's that phrase? We're not in Kansas anymore or something like that? What I'm trying to, what is it? What is it?
I think it's, I'm not in Kansas anymore.
I'm not in Kansas. Yeah, you're not in Kansas
She's talking to
anymore.
her dog,
Yeah,
isn't
she's
she?
talking to her dog, yeah.
She's talking to her dog. She's like, oh, you're not in
Yeah,
somewhere
right.
anymore.
So your dog is Regis Chemistry. You're not in Kansas anymore. So, put your big boy pants on, big girl pants on. Solve it. You do it, Tal. It's in there. So, you got your silver nitrate, you're adding NaCl to it. So you have a beaker with silver nitrate, you're sprinkling salt into it. You want to add enough salt to precipitate all the silver out of it. So maybe we should first understand what's the reaction going on here. I wrote it on the board earlier talking about the problem set. So when NaCl and AgNO3 react, what do you get? NaNO3, which is useless, and AgCl. So you're going to form AgCl. Okay, so that's your product. It wants to make sure you add enough NaCl to get all the silver ions from the reactant into the product. So you need enough salt to do that. you need enough Cl minus. So I would write out the equation first. Write out the balanced equation, and then go from there. So NaCl plus AgNO3 yields AgCl plus NaNO3. It's all balanced 1 to 1 to 1 to 1. This is not tricky that way. You know how much silver nitrate you have, so you can figure out your moles of silver nitrate. Right? You have your molarity, you have the volume. You can find moles of silver nitrate, which really means moles of silver. And then there you go. So find moles of silver, after you write the equation, find moles of silver nitrate. And then go from there. There's no place like home. That's what she says. Once you have an answer, raise your hand or get my attention. Let me see what you got. Feel free to talk to somebody. we have answers? The answer is, what's the question even asking again? Mass of NaCl. 8.77 grams.
Yeah.
Okay, so let me go through it quick, especially for our friend Skylar here. NaCl plus AgNO3 yields AgCl plus NaNO3. All right, once you find your moles of this right here, you need the exact same amount of moles of this, which you can convert to grams. So if you take 0.1 moles per liter, right, multiplied by 1.5 liters, your liters cancel. So moles of AgNO3 is 0.150 moles, right? So that's how many moles of AgNO3, which means moles of Ag+. So we have 0.150 moles of Ag+, so we need 0.150 moles of Na+. We need the same amount because when they're floating around, they'll come together and make AgCl, right? Or not NaCl, I'm sorry, or Na+, Cl-. So we need the same number of moles of this. So we have 0.150 moles of NaCl times 58 grams over 1 mole. Moles cancel, and that's 8. I got 8.77 grams. I don't know why, but that's it. All right, don't forget the worksheets due tomorrow. And if you need help with anything, come up and talk to me right now so we can figure out when we're going to meet.